Hey everybody, back with another Polars tutorial. Hope you're all doing real well. So today I'm going to be continuing my discussion on Polars temporal variables, namely using date-time variables and duration variables to do event history analysis. Now, in the last video I did, I calculated the time between two events using the earthquake data we see right here. And namely, each record in this earthquake data we have represents an earthquake. So each record is an earthquake, and each column is a characteristic of that earthquake, namely the date of that earthquake. So if we wanted to find the time until one earthquake and the one that occurred after it, all we had to do was calculate the duration between this date and this date. Or for this earthquake, on the third record, this date and this date. And so that's very easy. But now we're going to ask a question. We're going to kind of raise the complexity a little bit and ask what happens when we have records that aren't associated with the event of interest. And so in this video, what I'm going to be doing is going over the duration of time between one tsunami and the next. So an earthquake associated with the tsunami. And so how can we calculate the amount of time that elapses between this first tsunami right here and the one that happens after it? And then after the second tsunami, the amount of time that happens between this one and this one right here. And that's kind of a complicated thing when you're dealing with a duration column, because your instinct would be to create a cumulative sum of that duration. And that would work for this first tsunami right here, but then we would want that duration count, cumulative count, to start over for the second duration, right? And the third duration, and so forth, because this event can occur multiple times, but not every time for every variable. So that can become programmatically and just kind of, psychically kind of like a difficult thing to think through and program through. And so I'll show you the strategy and the technique I use for this type of event history and duration analysis when it becomes maybe a little bit more complicated. So how do we calculate the duration of time between events when the event does not occur on some records? And that's a key point. And so I did this in 5 steps. And so the first step is pretty simple. We're going to do exactly the same thing that we did in my last video. We're going to compute the duration of time between each record. So we're going to take the difference, in other words, the amount of time between this date and this date, and we're going to do that between every record because we need to know how much time had elapsed between every record. And we can take the cumulative summation of time between this second tsunami and the first tsunami, and that'll give us the duration of time for this record right here, the duration of time until this event occurred. And we're going to do that for every record. And then we're going to identify the start and stop records, in other words, the start and stop times. So we need to know when to start counting time for a new event and when to stop counting time for that event, and when to start the counter over again. So the start and stop times are going to be after an event for the subsequent event, and the stop time is going to be at that event. So here, for this tsunami, if we wanted to know the amount of time that occurred between this tsunami right here and the first one, this is going to be the stop time, and this first record right here is going to be the start time. Likewise, for this third one right here that we want to get the amount of time for, this record is going to be the stop time, and this record is going to be the start time. And we're going to be interested in all these records in between to get the cumulative duration. And second, we're going to identify the records in between the start and stop records, and we're going to assign these records to groups. In other words, the stop time and all records prior to the start time. So in other words, we want to be able to assign this record and all of these records right here to the same group, so we know that we need to sum the duration of time of all these groups together to get the amount of time that elapsed between this event and this event. And then finally, after we do all that, and this may sound a little bit schematic, it'll be maybe a little bit more clear after we take a look over the code. We'll take the duration of the sum of the duration grouped by group ID and country. So this group ID that we're going to create, we're going to take that sum of that, but we're also going to group it by country because there are multiple countries in here. I'm just showing Albania, one of the first countries, just to kind of keep things simple. But every single country in the world is in here. All right, so let's go ahead and get into it. So the first thing we're going to do is we're going to compute the duration of time between each record. In other words, how much time elapsed between this first record and this record right here. And the code I'm using for this is very similar to the code I used in my previous program. But just in case you didn't watch that video, I'll go over it here. So we're going to start by pointing to the column we want, so plcall date. And so we're pointing to this date column right here. And we're going to do a diff. And so what diff does is it takes the current record and it subtracts that value from the previous record. So it subtracts this record right here from this record, and it'll subtract this record from this record, and so on and so forth. So it's a very easy way to work with longitudinal data where the data is arrayed across a column rather than a series of columns. And when you subtract two records from one another, what you're going to get is a duration column. And what we want to do here is express our duration in terms of total days. And so to do that, we do .dt and then .total days. And then we want to do this whole operation over country because there are multiple countries in here. And we're going to call this column duration. And so we'll just go ahead and run this and see how it looks and just kind of get a feel for our duration data. Okay, so the first column should be null because there's no previous record for this first column to do a diff by. But here's our duration data. So what this column represents is that there was 1,461 days between this earthquake and the earthquake that came before. So we now have duration between each constituent earthquake. Now we need to use these duration values to get the total amount of time between each tsunami. So how do we do that? So next step number 2, is we need to identify the start and stop records. And so this is maybe a more complicated method chain that I have here. I do have this in a method chain rather than bracketing it out into individual steps just because I want to keep my code compact. So the first thing we're going to do is we're just going to identify where the tsunamis occurred, and those are going to be our constituent start and stop records, and that'll be how we're going to assign these unique group IDs. So we'll do plcall, and we're going to point to flag tsunami, and whenever we see this value of TSU, we're going to do something very simple. We're just going to give it a value of 1. And so just to maybe visualize this a bit more, so we're not just looking at a wall of code, we're looking at data, I'm just going to go ahead and run that, and we'll see that it's actually quite simple what we're doing here. Okay, so now all the tsunamis are flagged with a value of 1, but we want these tsunamis to have unique IDs because they are discrete events, and that's what we need to do. We need to calculate the amount of time that elapses between these discrete events. So one easy way to do that is to just take these and do a cum sum on them. And what cum sum is going to do is it's going to cumulatively sum all these. So this will have a value of 2, this will have a value of 3, and we just kind of cumulatively add a value of 1 to that running counter. But we're going to want to do that grouped by country because, again, there are multiple countries in here, and we want this analysis we're doing to be distinct within a country. So we'll go ahead and run that cum sum, and we'll take a look at that. Okay, there we go. So we see that this tsunami right here has a group ID of 2 because it is the second tsunami. This one has a group ID of 3. And the maximum value shows that, throughout history in Albania, there's been 8 tsunamis. So now we need to take this final step and we need to flag these constituent records to show that we need to sum all these duration values here to get the amount of time that occurred until this 8th tsunami right here. Same with this 7th tsunami. And so what I'm going to do is I'm going to do a backward fill. And I know I haven't talked about, filling in missing data here, but backfill or backward fill is a missing data method in Polars. And what it's going to do is it's going to take the first value it sees, and it's going to backfill that value and fill all the null values with it until it gets to another valid value. And so here it's going to fill all these values with an 8. It'll fill all these values here with a 7. These values with a 6, and so on and so forth. And that'll give us a really easy group ID to sum over. Hey, all right, there we go. So now that we have this group ID, we can clearly see the records that we need to take the sum of in order to get the amount of time that elapsed between this tsunami right here and this tsunami right here. We're just going to take the sum of these records, and to do that, all we have to do is do a grouped summation of 2 variables. We just have to take the grouped sum of country because these data are bracketed out by country, and we also need to do it by our group ID here. And we do have a null ID here, and the reason for that null value is because there's no tsunami that occurred after this 8-1. Thankfully, right? I mean, that would be bad. And this is okay. We can just discard these records for analysis once we're at that point. Okay, so next we're going to take the sum of the duration grouped by the group ID and country. And the way we do that is very easy. Much easier than what we saw before. So we just point to our column, duration. So it's going to be this column right here, the amount, which represents the amount in time and days between the first earthquake and the last earthquake. And then we're also going to sum it by group. So this group ID that we created. And we're going to call this time until event. And we're using dot over because we don't want to collapse our columns just yet. We just want to append those or merge those back to our original data frame, just so we don't lose that extra bit of context, just yet at least. Okay, so there we go. We see that, so this first record here, even though this is a tsunami, it's going to have a duration of 0 because it occurred at the beginning of the time series. So we have no extra date information to determine how much time occurred between this one and the last one. So we're just willing to accept that for now. So we see that this tsunami, the amount of time that occurred between this tsunami and the second one was 147,558 days. And we did that by taking that sum and grouping it by country and group. So now that we have those, we can really easily get some useful information of those. So the first thing we're going to do is we're going to filter this data by tsunami flag. We're just going to get, and so the way we do that is we do dot filter and then tsunami flag equals SU, or TSU, and that way we don't have any of these repeated values. We just have the records that we're interested in. And then we can do some really easy and really useful and informative descriptive statistics on these. So we can group by country, and we can ag, and we can create custom columns. So the mean time until an event, So the mean time until the next event or the next tsunami, the median time between the next event or the next tsunami, and then the number of tsunamis. And so we do dot mean, dot median, and then dot max on group. And the reason we're doing the max on group is because, again, group is just a group ID for each unique tsunami that occurred within a country. And so the max is going to be the maximum number of tsunamis that occurred. So we will just print this. I don't know, I don't have a print down here, huh? Okay, print. Oh wait, we already do. I'm sorry. I apparently need my glasses. So let's go ahead and run this and take a look at our final data. Okay, so a very interesting table we ended up with, right? We have a country. We have all our countries in the world. We have a column for the average until the next tsunami. So we can see here, let's go to one that experiences frequent tsunamis, maybe like Japan. So we see in Japan, it's an average of 1,689 days until a tsunami, a median of 300, which is pretty surprising. And you can see that throughout history, they've had 288 tsunamis, recorded tsunamis. Okay, guys, so that's how I handle event history analysis in Polars using Python. We can see it can be very tricky to work with data when everything's arrayed across a single column like that, but when we use the really powerful tools in Polars like .diff, .over, .groupby, .ag, and backward fill and QMSUM, and method chaining, it makes it a very doable task, much more doable than a lot of other data science packages that I've worked with. So thanks so much for listening, and